Welcome to Career Guidance Max playlist. In this video, we are going to see type 3 model symmetric matrices with the non-repeated eigenvalues. So, in finding eigenvalues and eigenvector in this type 1 and type 3 are more or less same only. Okay, so I'm going to find eigenvalues and eigenvector for this matrix. The given matrix I'm going to write, consider A is equal to 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3. Okay, so this is 3 by 3 matrix. First I'm going to form the characteristic equation. So which is 3 by 3. So we have to take characteristic equation also 3 by 3 model. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So based on this characteristic equation, I'm going to find what is S1, S2, S3. Already we know S1 we can find based on trace of A. What is meant by trace of A? Sum of diagonal element in the matrix. So I'm going to add 8, 7 and 3. So our S1 answer is 18. So next I'm going to find S2. So S2 equal to sum of minus of the main diagonal elements. So based on diagonal element, I'm going to find minus. So first I'm taking 8, first diagonal element. Based on that, I'm going to find the minor values. So if I have taken 8 now, this row, this column omit, remaining you can write in determinant form 7 minus 4 minus 4 3 and plus second diagonal element 7 I'll take. So this row, this column omit 8 2 2 3 8 2 2 3 write in determinant form and plus third diagonal element 3 based on this row, this column omit, remaining I will write 8 minus 6 7 in determinant form. Now we can simplify this determinant values. 7 into 3 21, 4 into 4 16 minus 16 and plus 8 into 3 24, 2 into 2 4 minus 4 and plus 8 into 7 56 and minus 36. 21 minus 16 5, 24 minus 4 20, 56 minus 36 20. So your S2 is 45. Next we have to find S3. S3 is determinant of A. That is, so S3 equal to determinant of A. Given matrix we have to write in determinant form. That is, I am writing 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Now you can apply the determination rule. 8 of this row, this column omit, remaining you can cross multiply. 7 into 3 21 and minus 16 4 into 4 and minus of minus 6. Now omit this row and this column, you will get minus 6 into 3 minus 18, 2 into minus 4 minus 8, in formula minus into minus plus 8 and plus 2 of this row, this column omit, remaining minus 6 into minus 4 I will write 24 and minus 2 into 7 14 and simplify this. 8 into 21 minus 16 5 and minus into minus plus 6 minus 18 into 10 minus 10 minus 18 plus 8 you will get minus 10 and here 2 into 24 minus 14 you will get 10. 8 into 5 40, 6 into minus 10, minus 60, 2 into 10, 20. So therefore, our S3 answer is 40 plus 20, 60, 60 minus 60, 0. So now I am going to write the characteristic equation. Lambda cube minus S1 is 18 lambda square and plus S2 is 45 lambda and minus S3, that is 0. So which is our the characteristic equation. Then now I am going to find eigenvalues. So the forming of characteristic equation is cubic equation. So we have to apply synthetic division method and write lambda cube coefficient is 1, lambda square coefficient minus 18, and here no need to apply synthetic division. See, in your characteristic equation, final term will be in the form of lambda, right? Here there is no constant term. So easily we can find eigenvalue here. So I'm going to take outside lambda from this characteristic equation. I'll get lambda into lambda square minus 18 lambda plus 45 is equal to 0. Equating to 0, you will get 1 root is lambda equal to 0. And this one I'm writing lambda square minus 18 lambda plus 45 equal to 0. So this lambda square minus 18 lambda plus 45 is quadratic equation. We will convert easily as a linear factor. So take last constant number 45. Which two number gives 45? When we multiply, it gives 45 means 15 into 3. So 45. But when we add this two, you should get minus 18. So that here I will add minus. Add this two, you will get 18. So that I am writing here lambda minus 3 and lambda minus 15 is equal to 0. Now equating to 0, you will get lambda equal to 3 and lambda equal to 50. Right? So therefore, your eigenvalues are lambda is equal to 0, 3 and 15. So next I am going to find eigenvector. The formula is a minus lambda I into capital X equal to 0. Here A is given matrix 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 and minus lambda into I is identity matrix. Depend upon our given matrix, I will take 3 by 3 matrix 1 0 0 0 1 0 0 0 1. This capital X we have to find, that is eigenvector x1 x2 x3. We are going to find this value is equal to 0. So again I'm writing 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 and minus multiply with lambda, you will get lambda 0 0 0 lambda 0 0 0 lambda. Now you can subtract these two matrix. I'll get 8 minus lambda minus 6 2 and second row minus 6 0 7 minus lambda and minus 4 0 2 minus 0 minus 4 minus 0 3 minus lambda and multiply with x1, x2, x3 is equal to 0. Okay. Now first matrix row wise, second matrix column wise, we can multiply, you will get the equation 8 minus lambda into x1 minus 6x2 plus 2x3 equal to 0. And second row and x1, x2, x3 minus 6 into x1 plus 7 minus lambda into this x2 minus 4 into x3 is equal to 0. And next one 2 into x1 minus 4 into x2 plus 3 minus lambda into x3 is equal to 0. Consider this is the general equation of I. From this general equation, we have to apply our eigenvalues. This type is 3 symmetric matrices and non-repeated eigenvalue. So the given matrix is symmetric and eigenvalues are non-repeated. Distinct eigenvalues are there. So I am going to substitute one by one our eigenvalues in this general equation I. So case 1, I am going to substitute lambda equal to 0 in equation I. So when I am substituting here lambda equal to 0, I will get 8x1 minus 6x2 plus 2x3 is equal to 0, which is equation number 1. And in second equation, you can substitute lambda equal to 0, you will get minus 6x1 plus 7x2 minus 4x3 is equal to 0, which is equation number 2. And substitute in third one lambda is equal to 0, I will get 2x1 minus 4x2 plus 3x3 is equal to 0, which is equation number 3. When substituting eigenvalue lambda equal to 0, we will get system of linear equation. If you want to apply cross rule method now, the equation should be different, at least minimum 2 equations. So can I see first 2 equation? First equation 1 and 2 are different equation, right? 1 and 2 are different equation. We can able to apply cross rule method. So I am going to write now x1 and x2 and x3. I am going to find eigenvectors of small x1, x2, x3. So taking equation 1 and 2, if you want to find x1, omit the x1 coefficient. Remaining coefficients you can write in determinant form from the equation 1 and 2. Minus 6, 7, 2, minus 4. And x2, omit x2 coefficient and remaining you can write in determinant form. First you can write always x3 coefficient, that is 2 minus 4, and x1 coefficient 8 minus 6 from the two equations. And I am going to find x3, that means omit x3 coefficient from the both the equations. Remaining you can write in determinant form 8 minus 6 minus 6, 7. x1, x2 coefficients in these two equations. And simplify this, x1 divided by minus x minus 4, you will get plus 24, and minus of 7 into 2, 14, and is equal to x2 divided by 2 into minus 6 minus 12, minus 4 into 8 minus 32. In our formula minus into minus plus 32 is equal to x3 divided by 8 into 7, 56, minus 6 plus 36 minus 36. So x1 divided by 10 and x2 divided by 20 and x3 divided by 20. So commonly we can divide it by 10. We will get x1 divided by 1 and x2 divided by 2 and x3 divided by 2. Okay, so therefore the first eigenvector x1 is equal to 1, 2, 2. This is our first eigenvector. So next I am going to substitute second eigenvalue, that is lambda is equal to 3. I am going to substitute in the general equation of I. Here lambda is equal to 3, you can substitute 8 minus 3, 5 x1 minus 6 x2 plus 2 x3 is equal to 0. Equation number 4. Then in second equation substitute lambda equal to 3 minus 6 x1, 7 minus 3, 4 x2 and minus 4 x3 is equal to 0, which is equation number 5. So next third equation 2x1 minus 4x2. Here substitute lambda is equal to 3, 3 minus 3, 0 is equal to 0, which is equation number 6. So when I am substituting actually lambda equal to 3 in our general equation I will get 3 different system of linear equation. Okay, so we can apply cross rule method from equation 4 and 5 by cross multiplication method. I'm finding x1, x2 and x3. So I'll consider equation 4 and 5. First I'm going to find x1. So omit x1 coefficient, remaining you can write in determinant form. So the coefficients are minus 6, 2, plus 4, minus 4. So next I'm going to find x2. So omit x2 coefficient from this equation 4 and 5. Remaining you can write in determinant form. When finding x2, always first you can write x3 coefficient, that is 2 and minus 4. Now you can write x1 coefficients 5 minus 6. Last one I'm going to find x3, so omit x2 coefficient. Remaining you can write in determinant form 5 minus 6 minus 6, 4. So simplify this, x1 divided by minus 6 into minus 4 plus 24 and minus of 4 into 2, 8 is equal to x2 divided by 2 into minus 6 minus 12 minus 4 into 5 minus 20, already minus plus 20 is equal to x3 divided by 5 into 4, 20 minus 6 plus 36, formula minus 36. So therefore we will get x1 divided by 24 minus 8, 16, and x2 divided by minus 12 plus 20, 8, and x3 divided by 20 minus 36, you will get minus 16. Now commonly you can divide it by 8. You will get x1 divided by 2 and x2 divided by 1 and x3 divided by minus 2. So therefore the second eigenvector x2 equal to 2, 1 minus 2. Okay. Then case 3. Now I am going to substitute third eigenvalue, that is 15, in our general equation I. So 8 minus 15, you will get minus 7 x1 and minus 6 x2 and plus 2 x3 is equal to 0, which is equation number 7. And second equation I am writing minus 6 x1. Here I am substituting lambda is equal to 15. That means I will get minus 8 into x2 minus 4 x3 is equal to 0, which is equation number 8. And third equation I am writing 2x1 minus 4x2. Here we can substitute lambda is equal to 15. 3 minus 15 we will get minus 12 x3 equal to 0, which is equation number 9. When I am substituting lambda equal to 15 eigenvalue in our general equation I will get new system of linear equation. I mean 3 equations we will get. Again we have to check whether it is different or same. So these 3 equations are different. From this any 2 you can take. Usually I am taking first 2, 7 and 8. I am going to apply by cross multiplication or cross rule. Okay. So now I am writing x1 and x2 and x3. So based on equation 7 and 8 I am going to find x1, x2, x3. So if you want to find x1, omit x1 coefficients. Remaining x2 and x3 coefficients you can write in determinant form. So I am writing minus 6, 2, minus 8, minus 4. And the x2 coefficient. Omit x2 coefficient. Remaining you can write in determinant form. First you can write a x3 coefficient, that is 2 minus 4. And now x1 coefficient minus 7 minus 6. And I am going to find x3. So omit x3 coefficient. Remaining you can write determinant form minus 7 minus 6. And minus 6 minus 8. So now I am going to simplify this. X1 divided by 6 minus 4 I will get plus 24. 8 into 2 minus 16. So formula minus plus 16 is equal to x2 divided by 2 into minus 6 minus 12 minus half minus 4 into minus 7 28 and equal to x3 divided by minus 7 into minus 8 plus 56 minus 6 into minus 6 plus 36. So I am writing x1 divided by 40 equal x2 divided by minus 40 and equal x3 divided by plus 20. So commonly we can divide it by 20. You will get x1 divided by 2 and x2 divided by minus 2 and x3 divided by 1. So therefore our third eigenvector is x3 equal to 2 minus 2 1. This is our third eigenvector. Okay. Now I am again recalling that. So in this video we taken one symmetric matrices with the non-repeated eigenvalues based on problem. So we solved this 3 by 3 matrix based on characteristic equation also 3 by 3 lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Here based on this, here I am going to find s1, s2, s3. You know how to find s1, s2 and s3. After finding s3, we substituted those values in our characteristic equation. We will get entirely different equation. If you want, if we solve this equation, we will get eigenvalues. So we solve this characteristic equation. We will get the eigenvalues lambda equal to 0, 3, 15. So after that we have to find eigenvector. So we identified eigenvector a minus lambda e into x equal to 0. When solving this equation, we will get this system of equations. So from this equation, we are going to substitute one by one lambda equal to 0, lambda equal to 3 and lambda equal to 15. When I am substituting lambda equal to 0, we will get the answer eigenvector of x1 equal to 1, 2, 2. Okay. and again you can substitute lambda equal to 3 in that equation. You will get eigenvector of 2, 2, 1, minus 2. So after that finally we substitute lambda equal to 15. I will get the eigenvector x3 equal to 2, minus 2, 1. So in this video we solved only one problem in this type 3. Remaining problems you can practice yourself. Do you have any doubt on this? You just refer the previous video which I was given in this type 2 model. In this type 2 model last I given the basic conditions how to apply eigenvalues while finding eigenvector. Okay, what are all the concepts we have to follow while finding eigenvector? I given clearly in while solving type 2 model problems in the last end of this video, end of that video. Okay, just go through that. Thank you, Pa.